Welcome to Study Loop.
We're asked to find the probability that a randomly selected teacher earns between $35,000 and $45,000 a year. So we can express that as the probability that a teacher earns between $35,000 and $45,000 a year. And we're given that the average annual salary, or mu, is equal to $47,750. That this distribution is normal, which means that we can use the formula Z is equal to X minus mu over sigma. We're also given that sigma, or the standard deviation, is equal to 5,680. So the way we're gonna attempt this problem is to find the Z value for these separate conditions, for 35,000 and 45,000. So let's set this one as Z1 and this one is Z2. So then what we're gonna get is Z1 is equal to 35,000 minus mu, which is that value, which is 47,750, over sigma, 5,680, and we know that this value is equal to negative 2.24. Now we're going to do the same thing for Z2, which is equal to 45,000 minus 7,750 over 5,680. There we go. And we know that that is going to equal negative 0.48. So now that we have this, we can rewrite this original expression as probability that negative 2.24, which is the Z value for 35,000, is less than Z, which is less than negative 0.48. And now what we're going to do is check out the Z table and find the corresponding probabilities of these Z values. So for negative 2.24, we're going to get 0.0125, and for negative 0.48, you're going to get 0.3156. So now we can then rewrite this as follows, as the probability that Z is less than negative 0.48 minus the probability that Z is less than negative 2.24. And then we know that this is the same thing as this. So we can just plug that in here, substitute the values in, 0.3156 minus 0.0125, which gives us 0.3031. And that's our final answer for part A. Now part B is slightly different. It's asking us for the probability that the teacher earns more than $40,000 a year. So we can write that as the probability that X is greater than $40,000. So to solve this, we're just going to use the same formula, which is Z is equal to X minus mu over sigma, and we know that mu and sigma stay the same. Mu is 47,750 and sigma is 5,680. So if you just go ahead and substitute the 7,750 and the 5,680, we're gonna get a value of negative 1.36. However, usually when we use this formula, this needs to be a less than sign. And since it's not, we're gonna have to do 1 minus the Z value. We're gonna have to do probability of Z is greater than negative 1.36 is equal to 1 minus the probability that Z is less than negative 1.36. So that is an equivalent statement, and it's useful for us to write it like this, because here we can find this value right here using this formula and just do 1 minus to get the greater than, which is what the question is asking. So now if we find the corresponding value for negative 1.36 from our Z table, we're going to get 0.0869. So then if we substitute it back into here, you get 1 minus 0.0869, which is the corresponding probability to this Z value. And that gives us a final answer of 0.9131. And for part C, the question is asking us that if you were offered $31,000 a year for this position, how would you feel based on the information? And so there's no real calculation that you need to do this for this part, but you just need to look at your parts A and B and use your logical thinking to determine an answer. So here we can tell that the probability that a teacher earns more than $40,000 a year is 0.9131, which is the same thing as 91.31%. So 91.31% of teachers earn more than $40,000 a year. Therefore, if you were offered $31,000 a year, you wouldn't be too happy, because most teachers would be making a lot more than you.